Hello all, welcome to Surjith Varma YouTube channel. In this video, I am gonna tell how to find shape of the molecule. I will say the easiest way, just listen and don't skip the video, watch till the end. Required information to find the shape of the molecule. First one is what is the central atom, that is represented by A, and the second one is to how many atoms it is bonded, that means the how many atoms are bonded with the central atom. Third one is number of bond pairs. By knowing the second information, we will come to know how many number of bond pairs are present and how many number of lone pairs are present. Those are represented by Bx and Bey. B means bond pairs, X means number of bond pairs, E means empty pairs or lone pairs, Y means number of lone pairs. It is represented as A, Bx, Ey, where A is central atom, B is bond pairs, E is lone pairs, X is number of bond pairs, Y is number of lone pairs. So now how to find number of bond pairs and lone pairs? It is very easy method. Let us see some examples. The first one is carbon dioxide. We know in the carbon dioxide molecule what is the central atom? That is carbon. A is central atom is carbon. And how many bond pairs and lone pairs are present? We know that the valency of carbon is 4. So we can draw 4 electrons. So with using these valence electrons, it will form the bond. Now oxygen is divalent. 2 oxygens are present. So one oxygen will form bond with 2 electrons of carbon. So 2 oxygens will form 2 bonds with 4 carbon electrons. So one bond pair, second bond pair. Therefore central atom A, B2, and here no lone pairs. So here the geometry of the carbon dioxide molecule is linear. And how the geometry will be found? So by seeing the number of bond pairs and lone pairs, we'll get what is the hybridization, what is the geometry, what is the bond angle. This all information will be presented in a table form in the next slide. Just watch the examples. And here 2 bond pairs are present. So what will be the hybridization? That means 2 bonds are formed. That is, one is s orbital and other is p orbital. Sp hybridization. And the second example is NH3. In ammonia NH3 molecule, central atom is nitrogen, and we know that nitrogen valency is 5. And you all know that valency means it is the capacity of an atom to form bond with other atoms. So 5 electrons are there in the nitrogen atom to form bond with other atoms. So here other atoms are 3 hydrogens. So here the bond pairs are 1, 2 and 3. So A is central atom, 3 bond pairs, and what is the lone pair? Pair means 2 electrons. Therefore AB3 E1. So therefore 4 bonds are formed. That means S, 1SN, 3P, and the geometry is pyramidal. How the geometry is came? I'll tell in the next slide. And PCl5, same. Phosphorus has 5 electrons as its valency is 5. Central atom is phosphorus and it forms 5 bonds with chlorine. So therefore there are 5 bond pairs. Now central atom B5. Its shape is trigonal bipyramidal. Now how the shapes are there, how the shapes are found, it will be explained in the next slide. Summarize this table in order to find the shapes and the geometry and the hybridization and bond angles. Here see, these are the total electron pairs present. Bond pairs, that is number of bond pairs, those are X, and lone pairs, number of lone pairs, that are Y, and the type of molecule, that is the formula, shape of the molecule, hybridization, bond angle, and those are the examples of the following geometry mentioned here. For example, Here if we take two electron pairs, if two bond pairs are present and zero lone pairs, it is represented as AB2 and the shape is linear and the corresponding hybridization is sp. Since two bonds are formed, one s and one p, and the bond angle is 180 degrees. And examples are CO2 and BeCl2. Next, three electron pairs in which three bond pairs, zero lone pair. Zero lone pair means you don't have to mention E here. So the type of formula is AB3. The shape is trigonal planar and the hybridization is sp2. So the bond angle is 120 degrees. The examples are SO3, COCl2 and BCl3, boron trichloride. Next, two bond pairs, one lone pair, AB2, E1. Shape is V-shaped and hybridization is sp2 and the bond angle is 104 degrees and the example is SnCl2. Now, four electron pairs. That means if there are four bond pairs, then it is tetrahedral. If three bond pairs and one lone pair, it is trigonal bipyramidal. And these are the hybridizations. Those all are for the electron pairs 4. Number 4, the hybridization is sp3. And the bond angles are corresponding to the each respective shape. Tetrahedral 109.28 degrees and the example is methane. And for trigonal pyramidal, example is NH3. And now two bond pairs and two lone pairs, that is AB2 E2 type. That means angular and V shape. Angular or V shape. The hybridization is sp3 and the bond angle is 104 degrees. And the example we all know H2O in the previous example. Now, as we can see 5 electron pairs, if 5 bond pairs, 0 lone pair, then it is a B5 type. Shape is tri-bipyramidal and the hybridization is sp3d and the angle is 90 degrees, 120 degrees, 180 degrees. Example is PCl5, phosphorus pentachloride. Now, 4 bond pairs, 1 lone pair, that is AB4 E1 type, seesaw structure, having the hybridization sp3d and bond angle 90 degrees and the example of the molecule is, of the shape is SF4. We have 3 bond pairs and 2 lone pairs. The type of the molecule is AB3E2, shape is bent T-shape or T-shape with hybridization sp3d with bond angle 90 degrees and example is CIF3. Now if we have 2 bond pairs and 3 lone pairs, then the type of the molecule is AB2E3 with the shape linear with hybridization sp3 and the bond angle 180 degrees and the example is ICL2. And now if we have 6 electron pairs, 6 bond pairs, 0 lone pairs means it is octahedral and the hybridization is sp3d2 with 90 degrees and 180 degrees bond angles. That means these molecules have 2 bond angles in between the adjacent atoms. And the example is SF6. Now if we have 5 bond pairs and 1 lone pair, AB5E1, square pyramidal shape, the hybridization is sp3d2 only and the angle is 90 degrees. Example is ClF5. If we have 4 bond pairs and 2 lone pairs, AB4E2, shape is square planar, sp3d2, 90 degrees bond angle. Example is XCF4. If we have 7 electron pairs, 7 bond pairs, that means AB7, having the shape heptagonal bipyramidal and the hybridization is sp3d2 with 2 bond angles 92 degrees and 72 degrees approximately. And the example is XeOF5. Yes, in this way, we'll just have to memorize the table, and if we find these structures, these type of molecules, we'll easily find the shape, hybridization and bond angle. Yeah, this is the easiest way to find the shape of the molecule. This is according to the VSCPR theory, that is valence electron pair theory. So if you like this video, please like, share and don't forget to subscribe and hit the bell icon. Thank you.
It's caught in the crossfire.